Coding 101, we are going to flowchart your world and check out if-else statements.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
Coding 101 is brought to you by Jira, an Atlassian product. Jira is the project management solution for teams planning, building, and launching great products. To learn more about Jira and try it free for 30 days, visit Atlassian.com/C101. And by Lynda.com. Learn what you want, when you want, with access to over 2,000 high-quality online courses and training videos, all for one low monthly price. To try it free for 7 days, visit Lynda.com/C101. That's LYNDA.com/C101. Welcome to Coding 101. It's the Twitch show where we give you the knowledge to enter the wonderful world of the programmer. I'm Father Robert Balacer.
And I'm Shannon Morrison. Today we're going to take you on an amazing adventure of coding with Code Monkeys.
That's right, Shannon. Now, we know that the key to learning is repetition, right?
That's right, it is.
The key to learning is repetition, right?
That's right, it is.
The key to learning is repetition, and that's why we're going to show you snubs, compiled snubs. What are our users thinking of?
Well, we still have a few people that are interested in getting started on Xamarin Studio on the Mac and getting started on Visual Studio Desktop on the Windows PC.
Okay.
So I'm just going to run you through real quick again how to open up and get started in each of those. And I'm also going to show you my while loop because I actually got it to work.
Whoa.
It was so frustrating. I was making it way too hard for myself, but I got it to work and I was so excited about this.
That's normally how it works, right? I mean, we gum it up, we make it excellent. And wait a minute, take everything away and just make it work.
It's true.
All right, so show me what we got.
I was so angry too. I was like, no, you gotta work for me. So first I have my Mac PC. I almost said Windows. Mac PC, wait, that's kind of...
Mac thing, the Mac thingy.
Mac thing. So when you first open up Xamarin Studio, after you have it installed, it's going to look like this. We're going to go to New, click on New, to C# and a console project, because that's what we're working in right now. And then name your console project. So I'm going to call it episode, what episode are we on, 5?
Episode 4.
4.
Yeah.
4.
Now, I know that this is an important step because a lot of people are falling into the trap of picking like a template and not that blank worksheet. And what happens is then the code doesn't work properly.
Yeah, and then, everything is broken. So you definitely want to make sure that you're choosing console application every time you get into this program. So after that, you can start writing your code. So the one that I wanted to show you, and I have it pulled up in my Coding 101 doc, so I'm just going to copy and paste it over. There we go. And paste it. And I'll put this in the GitHub as well. Okay, so I'm going to delete a couple of extra little quotes here, because every time you do that from Google Docs,
it's all the rich text stuff you got to get rid of. Yeah, be careful of that, folks, because those quotation marks do count. So if you are copying and pasting from a rich text editor, anything but Notepad, essentially, you got to make sure that those curly quotes don't make it over.
Yeah, those are annoying.
Those are annoying.
So if we take a look at my code, basically up here we have the regular thing that you see at the beginning of each and every code. We'll get more into this in the future, but for now, just make sure that it's there. So here is the start of my while loop. So I started with 4, so it's a for loop.
For loop, yep.
For loop, yes. And then integer is counter equals 1. So that's where I'm going to start, is 1. And if the counter is less than or equal to 100, I'm going to make sure that the counter adds 1 each time that it does the loop.
Right. So going back to our lesson, that one line is going to initialize the variable that we're using as the counter.
Exactly.
It's going to set the condition, so it's going to run the loop as long as it's less than or equal to 100.
Right.
And then it sets the step, which is counter plus plus, so counter plus 1 every time it runs.
Counter plus 1.
All right.
And I love that counter plus plus. It's so easy.
Yeah, right.
And then down here at the bottom, I just included this console write. The count is currently blank, so I have a little space here for the number. So at the end, see, it's just a write, so it's not going to enter down to another line. Down here it says console write line counter. So that basically means it's going to say the count is currently whatever the counter number is, and then after that, we use the write line to enter down to another
Now, I like what you did there because by using right on that first line, it leaves the cursor on the same line.
Yes.
And then after it prints the number, it drops it down to the next line.
Exactly.
That's a very good use of right and right line.
And then I'm going to go up here. I'm just going to start debugging. And if there are no bugs, then it'll say completed successfully. It'll pull up my new prompter and it says the count is currently, and it starts all the way up at 1 at the top and it goes down, or it adds 1 every time up to 100 right here. At the bottom it says type enter to exit, and that's just the information right here that I've included that just says type enter to exit, and it's in magenta. So that's how I was able to change the color.
Right,
So
we got
hit
that straight
enter.
off of Lou's code.
Press
Yeah,
any key
nice.
to continue. Yay!
Very cool. Now, again, you've shown off a really common concept, a commonly used concept. In fact, Lou told us yesterday that he uses for loops almost exclusively. I said,
Yes.
you know, above 60%. And the only reason why I'm at 60% is because I deliberately try to use other loops.
Yeah.
But yeah, for loops tend to be the most useful loop that you've got in coding.
It seems very easy once you've actually done it a couple of times. This morning, I made it way too complicated for myself. At the beginner language that I understand, I included an extra console write in there, and then I had some extra user inputs. So I just deleted everything. I gave myself about 10 minutes to think about it, and I was like, you know what? I need to make sure that I'm just making this super easy for myself. So, you know, I don't want to make it too complicated.
Got it. Got it. All right, so that's your Mac, and of
That's my
course we're
Mac.
showing Mac love because a lot of people were
Yes.
saying, wait a minute, what about your Mac users? That was for you, but what about on the PC?
Yes, so I'm a little bit more familiar with the PC just because I've grown up with, you know, Windows, and I've also been playing a lot more with Visual Studio on the desktop. For Windows Desktop, that's the one you want to make sure you're downloading. And every time you open this, you'll go to New Project and then choose Visual C# Console Application. And then open it, and it'll give you the basic information as usual. So for this one, I copied and pasted the exact same code that I was using on my Mac. So you'll see the same for loop, the same console write, this count is currently the right line counter, the name of my variable. And then if I hit start on this one, it shows me the exact same thing.
Right. So
Yay.
two sets of code, one set of code, two different computers, the same output.
Computers. Yes, exact same output. Of course, it looks a little bit different because one's Mac, one's a PC, but basically same thing. Now, this did something funny to me, and I don't know the answer to this, and maybe somebody out there will. Why does it open this white window down here? That is so confusing to me.
debugging
I don't know
window.
why it's doing that.
You know what? That might be a good answer. A good question to ask our code warrior.
Yeah, I
who
agree.
knows? Yeah, he'll be coming later. Now,
He'll know.
at the end of last episode, we asked people to show off some of their work, right?
We did.
And you actually had a response.
I did, yeah. So I talked about the show on my other show, Hack 5, and one of my fans over there introduced me to his ASCII art. So this was on our Google Plus community. If you haven't checked that out yet, go over to Google Plus and search for Coding 101. And this is from Douglas Adams. So he made ASCII art with a bunch of write lines that basically says Coding 101 with Shanna Morse and Father Rob Balliser.
Now, it wasn't
So
just that,
cool.
right? He also gave us his
love
code.
it. He did. He gave us his code, and I love it. And it's on the second link that we posted. So this is his code. He put it up in Pastebin, and we'll include this in the show notes as well if you want to check it out and do your own drawing. But he basically just used a whole bunch of write lines and a whole bunch of dashes and parentheses and whatnot to create this whole line of his drawing.
Yeah.
It looks really cool. It's not a while loop.
It's not a loop.
for
It's
loop.
not a loop.
But it still uses something that we discussed in episode
Exactly.
2, I believe, to create something very cool. It was
Now,
neat.
the other cool thing about that is that that didn't use a for loop because he wasn't just doing the same line
Right,
over and over
exactly.
again. But we're eventually going to get to a point where we're going to be able to show you how using some loops with arrays, you'll be able to do ASCII art with just a single function.
Oh, that's cool.
Yeah?
I like
Yeah,
that idea.
That's pretty cool.
So, you want to move on to the
I
Ivory
think so.
Tower?
Let's jump into the Ivory Tower. Now, Snubs, way back in episode 1, so long ago, we talked about how we would take something from the real world and turn it into programming language. Do you remember
Yes,
that?
I do.
And specifically, we were talking about taking a binary a function and turning it back into decimal. Or was it decimal going into binary? You know, I
Yeah, we
can't-
did both of them. I think
Yeah, we did both of them. That's something from the real world that required some sort of mental process. You had to be able to break it down into chunks, right?
Yes. You had to do some math on
We
that,
had to do some
basically.
math. We had to do some math. And Lou wrote us a very nice black box function for us to show off how that actually works. But now we're going to show you how you can write your own decision-making statements.
Oh, cool.
Yeah.
Oh, this will be really handy.
Yep, yeah.
Okay.
This is all about the if-else statements. If you've been writing in Visual Basic, you probably know it as an if-then. I always call it an if-then. But the idea is it can choose between a right condition and a wrong condition, a true condition and a false condition, which we talked about, right?
Yeah.
Relational expressions.
Lou had an if in his code from last week.
Yes, he did. Now, remember when we talk about relational expressions from last week, we're talking about those symbols from math class. You remember these?
I remember those.
Less than, greater than, equal to, less than, equal to, or not equal to, correct?
Yes.
Yeah, so these are all the relational operators that we can use. And what will happen is when you put this inside of a parentheses and then put some sort of operand on either side, the condition will either be true or false.
Is an operand the same as a variable?
No, well, an operand is just on either side of the operator.
Okay.
It's what you do the operation on.
Ah, okay.
Yeah, yeah.
Okay,
all right.
got it.
Now, we're talking about if-then statements.
Yes.
What an if-then statement will do is it will look at the condition and say, if the condition is true, then run this code. If not, then continue on.
Oh, okay.
All right, so let's visualize what this looks like. And again, this is going to be pseudocode. Don't try to put this directly into your compiler, otherwise it will explode and you'll be mad at me. It looks something like
I
this.
did.
Yeah. If, and we know when we see this, we've got a condition, right?
Yes.
So if, then this. So whatever I'm going to write down here, it's going to go ahead and write it.
Okay.
Okay, so actually, let's bring one up here on screen. It's going to look like, what was my example? Oh, that's right, user input. So I want a user input. So I'm going to create an integer called user input.
Okay.
And what that does is that goes ahead and it initializes the memory. It sets aside some memory for user input. Then I'm going to say console write. And I'm going to ask it to say, please enter a number.
Okay.
And just pretend like I did that without the misspelling.
Please enter a number.
Please enter a number, okay? Now I need a console read, which we also know how to do. Console read. And I'm going to go ahead and read into the user variable that I just created, right? So user input. Now I'm going to be able to do operations on this. And the operation that I want to do is an if-then statement. I'm going to say if, now here's my condition, if user input is less than 0, then the write console write less than 0.
Ah, okay. Or whatever you want that to say.
Or whatever I wanted to say. Well, my handwriting is absolutely horrible. We really need a better board. But then I could also put an else statement. I could put else, and I could put another console statement here saying your number is greater than 0.
Like an error.
Right,
code.
an error code, right. So this is a really simple way of looking at what an if-else does. It allows me to take an input, and if it's true, I do one thing. If it's false, I do another.
Okay.
Does that make sense?
It does. I will have to play with that because it's a little bit more complicated.
It's a bit more complicated, and I can use all of those relational operators that I talked about before. So I could use less than, I could use greater than, I could use equal to, less than equal to, greater than equal to, not equal to. They can all fit inside this condition and let me know whether or not I'm going to run whatever code I write in the if and the else sections.
So let me review this. So first off, we have the user input. So say I'm doing this on my own computer. It says, please enter your number, and I put in the number, it'll be, what, 5?
5,
I'll say 5. So then it says read user input. The user input is 5. If 5 is less than 0, then it would go down to the else, right?
Less than, well, so if 5 is less than 0, then it's going to go ahead and write. So if
5 is greater
let's
than
take
0.
Let's say 5 is this. So is 5 less than 0?
No.
It's not, so it's not going to write less than 0. It's going to go down to the else, and the else would be greater than 0.
Yeah.
Correct?
Yes, it would give me whatever that error is if it was incorrect.
Exactly.
Yeah.
So that's as simple as we can make the if-else statement. Now, before we go crazy on the code, I want to model this after the real world, because that's what we did in episode 1. That's what really made sense. When we took a problem and we divided it into parts that people could understand in computer code. So I'm going to take a problem that I think a lot of us have. Snubs, you have a smartphone?
I do.
Would it be nice if your smartphone didn't always ring when you didn't want it to ring?
Oh, yeah.
Yeah.
Like
so,
when I'm doing shows?
When you're doing shows. Okay, oh, that's a good one. So how about this? Let's figure out all the times when you wouldn't want your phone to ring. When you're doing a show.
Yeah.
How about
asleep?
When you're sleeping, right? Sleeping at night.
Yeah.
How about when you're driving?
When I'm driving, yeah, that's a good one.
When you're driving. Okay, let's use those 3. So in a show, sleeping, or driving. Now, I can't just go into my compiler and say, if sleeping, don't do it.
It's not going to know if you're sleeping.
It's not going to know, right. But what we can do is we can start to think, okay, what data does the phone have access to? And I can write my code so that it uses that data. For example, what sensors do you have on your phone? It has time, okay? Probably has access to your calendar.
Yes, it has my calendar. What sensors? Oh, it knows speed.
Knows speed, exactly.
Yeah. Accelerometer.
Accelerometer. Has a camera too, right?
Yeah, it has a camera.
Okay, so let's use those 4 inputs. We know it has the time, it has the schedule, it has an accelerometer, and it has a camera.
Yeah.
I can now write a series of if-then statements to do exactly what we talked about, keeping that phone from ringing when I don't want it to. You want to see how it's done?
Ooh, yes, I do.
Okay, let's do it. All right, let's start with the first example. Okay, the first example was when I'm doing a show.
Yes.
Okay, so we want the phone not to ring when doing a show.
Yes.
All right.
Correct.
So the first thing we're going to take a look is at, let's look at the time.
Okay.
Okay. And we'll look at the time and at the schedule. So it's got my calendar. So the if-then statement would be if I am within the time of a show on the schedule. Right?
Okay.
So I'm going to say if, that's my if. Is it showtime?
Is it showtime?
Yeah. So is it showtime?
Right
If it's showtime and I put yes, then it's going to run to
too
off.
high, too high.
Oh, you can't see me because I can't see you. So I'm going to say if it's showtime, then yes, off. Turn off the phone.
Okay.
If it's not showtime, if it doesn't find that you have a show scheduled for the time that it currently is, it's going to say no, which is on. So it's going to be on. It's going to leave the ringer on. That one's very simple, right?
Yeah, that makes sense.
But let's look at the second example, sleeping. I don't want it to run while I'm sleeping.
But how does it know when I'm sleeping?
Exactly, right? Because it's not just related to time. It's not just related to your schedule, because you don't schedule your sleeping times. So I could look at multiple pieces of data. Let's look at the first one. The first one might be time. So it knows that I only sleep after 10 o'clock.
Yeah.
Okay, so here's my if, is it after 10 o'clock?
Yes.
If it is after 10 o'clock, so here's my yes. I'm going to hold that off for a second. Okay. If it's not, then I say, okay, go ahead and leave it on. But if it is after 10 o'clock, the phone has to do another check. It has to say, well, it may be after 10 o'clock, but maybe she's not asleep yet.
Yeah,
so what other data do I have access to? You said the motion, right?
Camera. Yeah, and the motion.
The motion and the camera. Okay, let's start with the motion.
Okay.
So I could say, okay, if yes, then now I ask, has the phone moved in the last 30 minutes?
Oh,
if,
so no.
Yes, so if it's no, if it has not moved in the last 30 minutes, then I know, oh, okay, so maybe if it's in one place, so that means continue to the next step. If it has moved on into the next, if the camera has moved, or if the phone has moved, then I know that she is still awake, so go ahead and leave it on.
Oh, that's cool.
But if not, then I need to ask the next thing, which is, let's look at the camera itself.
Okay.
The camera's going to say, well, do you see anything? Is it light or is it dark?
Yes.
If it's light, so is there light? If there's light, then I say, well, then there is light, leave it on, because she's still doing something even though it's late at night. If there is no light, then I turn it off, because now I know that it's after 10 o'clock. I know that the phone hasn't moved, and I know that the camera is not picking up any light, so therefore she's asleep, turn off the ringer.
That is so cool.
Right.
Okay.
Yeah.
That sounds really complicated.
It sounds complicated, but this is how we break down problems into something that a computer program can understand, right?
Okay,
Because like I
yeah.
said, you can't just say, turn off phone, 10 o'clock, been
that's
sleeping.
true.
But I can say, if you have access to the time, if you have access to the accelerometer, if you have access to the camera, you can check those 3 pieces of information, follow this flow chart,
Right.
and at the end, it will know, do I leave the camera, do I leave the phone on, or do I turn off the ringer?
And of course, this very complicated example would actually require all that information on your phone.
It would require all the information on the phone, but this is just a series of if-else
Yeah,
statements,
okay, that
right?
makes sense, yeah.
And now let's just talk
I
about that
get
third
if-else.
example. That third example
Or if-else.
of driving, right?
Driving, yeah.
So you work that out for me. How would I do that?
Oh boy. So if the car is in motion, or if my phone is in motion, then turn off the ringer. So that would be, yes, it is in motion, so off for the ringer. If it is not in motion, so that would be that square down
right.
at the bottom. If it is not in motion, keep the ringer on, so that would be a yes.
Boom, exactly.
Bam.
Bam. Yeah,
That's
and,
cool.
and as we add more decision
Could we say,
points.
like, if it's going far faster than a certain speed?
Sure, why not?
Because if I'm on BART doesn't go as fast as I drive in my car when I'm
Good point. Yeah.
the highway.
So why don't we say, okay, if the
If you're on
motion
the
is detected,
subway.
so the accelerometer detects motion.
Yeah.
Then first of all, I know that if it doesn't, then go ahead and leave it on.
No.
If it does, okay, now check the GPS sensor. Am I moving faster than 45 miles an hour? Because I know
Yeah.
the trains don't move any faster than 45.
Right. So if I'm on
no,
a train, keep it on, yes.
yeah,
If I'm in my car, it's going faster,
then
turn it off.
Turn it
no.
off. Exactly. And this is how
If
computer
else. If
program
else.
works. This is how
If else.
decision making works.
If else.
Yeah.
Thanks.
Whoa. All right, folks.
next.
Now we're going to be getting to the Code Word, but before we do that, we're going to welcome a new sponsor to the Coding 101
A new
family.
sponsor. Ooh,
That's
I like.
Atlassian. Now, have you heard about Atlassian at all?
No, who
So
are they?
they're a company that is really dedicated to helping startups, helping enterprises, helping companies that do
Cool.
coding projects or do technical projects. That's their entire thing. That's their focus, and that's what they're building with Jira. Now, Jira is one of the world's most popular and customizable issue and project management systems. It easily captures and organizes your workflow so that you can prioritize and take action on what's important while staying up to date with the activity that's going on around you. You can easily capture, organize, and prioritize your team's issues, tasks, features, and bugs. Give your team a simple, intuitive interface for collaborating with each other in real time. And we're all about that. We want you to be able to make the decisions that you have to make in real time. They can seamlessly integrate your planning documents, your backlog, your issues, and your code repository all on one platform. If you're a coder, you'll know how important this is because you don't want to have to send your developers to different sites, to different repositories. You want them to have a single pane of glass that shows them this is the project that you should be working on. Jira lets you set up any business process you can imagine so that your team works the way that they want, and you can define your own issue types to track the information that matters most to your team. You can stay in the loop with notifications via email, chat, @mentions, or RSS, and monitor streams of activities or self-updating reports and dashboards so that you're always in the know. Jira lets you expand infinitely in any direction with thousands of Jira add-ons, including test management, time tracking, project management, and hundreds of other uses. If your issues involve code, and here on Coding 101, all our issues involve code, Jira ties everything together from an initial planning doc to the files and change sets in your code repository, all the way to deployment. In other words, from the start to the finish. Jira's integration with Git allows teams to follow their code from development all the way through delivery in one system. And you can even build into Jira with the power of Atlassian's REST APIs. Jira is flexible and simple enough for a 5-person startup, but powerful and reliable enough for a 100,000-person enterprise. They're used by over 25,000 companies, including 70% of the Fortune 100 and even NASA itself. And they sit at the heart of Atlassian's offerings for managing your entire application development process from concept to launch. So here's what Snubs and I would like you to do. We want you to go to Atlassian.com/C101 for more information on Jira. Just check them out. Monthly plans start at $10 a month for up to 10 users, and you can try it free for 30 days. Remember, Atlassian.com/C101 and select Try It for free. And we thank Atlassian for their support of Coding 101. Well, Snubs, do you think we've confused the audience enough?
Yeah, I think so.
I think so. So how about this? Why don't we welcome our code warrior?
Yeah, let's do it.
That sounds like a good... Hey, Lou, can you hear us?
Hey guys, how you doing?
It's
Hi.
Lou Maresca from Microsoft. How about that? You're coming back to be our C# code warrior.
All right.
Now, Lou, we're talking all about if-else statements. We want these decision-making buggers to help us design our code. What do you got for us?
Sure. So I think last episode we actually went over the asking user for some text and then printing the text depending on how many times they want it to be printed. And so what we want to try now is going with the logic that you just showed, is using some if-then statements and some additional input. We can then ask them, hey, do you want to print this on a separate line or do you want to keep it on the same line? And so I think we'll just really fast, if you show my screen real quick, this is a normal program. We'll paste in the program from last time. And so we'll go over real quick what that looks like here. So you'll see that the first thing is we ask them what they want to type. We ask them how many times they want to type it. And then the next thing that we want to do is we want to ask the user. So I'll get rid of all this stuff so it's not less confusing. And we'll ask the user how many times they actually want, or if they want it on a separate line or not. So same exact thing. I do console write. And we basically say, hey, do you want to write it on a separate line? And from there, now we actually, again, we have to ask them for it. So we do that. So this is the read line. So they type, prints out, and then we read the line. And again, we get text here. And now we have to convert that to something that we can actually use logic against. So we have two options. One, we can do it using your fancy schmancy if-then statement. And I do that here by saying, I don't need this right now. That's confusing if I don't do that. I can say, hey, if this equals y, so that I ask them to put a y, yes or no. If that equals y, then it's most definitely going to want to be printed on a separate line. So I just set it to true. And I need another variable here that I can call on separate lines. Set it to false.
What is a bool?
And bool is just another type. It's like true or false.
Right. So
On
you
or
have,
off
you have an
kind of
integer
thing.
variable, which can be an integer. You have a bool, which can only be true or false. There's two
That's right.
possibles.
Oh, okay.
That's another variable type. And so what this is basically doing is the user types in a yes or no, and then we convert that yes or no text to some kind of a bool so that we can use it for later. And then we basically just switch around the current logic that we had. So we had some logic down here that basically took this. Let me make sure I have the sanitized logic in here for the number we have up here. Get rid of that. OK. So then we have some logic in here where we normally had that for statement where we loop around and we repeat the number a certain amount of times, however many times the user wants. But then we have this if statement. So we basically say, if this is true, then print it on a different line. But if it's not, if it's false, then write it on the same line. And so, again, we basically just using, true or false, real simple logic.
Right.
So if we run this.
So what you're doing in this piece of code is you've got that first if statement to look at the yes or no entry from the user. And all you're saying is if it's yes, then go ahead and set the Boolean variable to say true. If not, set it to false. And then you're using it again in the loop saying, look, if they said yes, so if the Boolean expression is true, go ahead and put it on its own line. If not, go ahead and write them one after the other.
That's right. So we used the if condition or Boolean logic twice. We basically said if this is equal, we have to use two equals here rather than just one equal. That's called a Boolean expression. And we say, hey, is this equal to y? Yes, it is. Then, OK, set it to true. And then down here, if it's true, then print it on a separate line. Exactly what you said.
Right.
And so if we run this, so you can say coding 101. Whoops. And we say we print it 3 times. And let's say I want it on a separate line. So there's my y. And there we go.
There we go. And go ahead and run it
again when you say no.
Yeah.
Sure.
Because we're trolls.
Moment of truth right now. There you go.
And it worked. Now you do have a space in between those. Is that because of the 0 in brackets within the parentheses?
That's right. That little formatter that we used
and
up here.
What is that called again?
called a formatter.
Format.
But you can also call a tokenizer, whichever one you want, whatever person you talk to, they say it differently. But it's a formatter, and we'll put the link in the code so that you can go check it out, how it actually works.
Cool.
Yeah. Now, we've got a good comment from a member of the chat room, M5, who says, Padre SJ, as an old fart, my old programs used to run from top to bottom and a sequence. This type of programming does not seem to work the same way. Very confusing. Lou, you know what? I remember getting this when I switched from BASIC, because I started with BASIC, into more object-oriented programming. Let's let the cat out of the bag. We've been asking our audience to trust us, but do you want to describe what goes on when you're programming with functions and how they call one another?
Sure. So sequential logic, they call it, there's a term that they call, it's called spaghetti code. And what happens is, over time, as you sequentially do things, you sometimes have to go and do other things at other parts of the program. And so what ends up happening is you start using go-to statements and these statements that take you around to different lines in the code, but then you have to kind of come back, and it just becomes all this mess of code. And so the way they get around that is two things. One, object-oriented program, which we haven't gotten into yet. And two, functions, creating functions where, you can basically wrap up some logic and stick it somewhere, sync or somewhere else, and wrap and put a name on it. So put a little label on it, like generate number or something like that. And then from then on, in your normal code, you can call generate number, and it will just do whatever code's inside that little wrapped up package that you have over there.
Right, right. It's actually a much more efficient way to code, right, Shannon? Because rather than having to write out every step that's possible, I could just say, look, if this happens, then call this function. If that happens, then call that function.
Yes.
If it does this, then run this sequence. It's a much more efficient way to code, and it's a really good way to reuse code, right, Lou?
That's right, exactly right. And so then you can start sharing your functions with people, and then that's the small package, and then you can start making objects which have a bunch of functions in them, and you can start sharing that with other people, and then it becomes much easier to kind of shift code and reuse code. They call it modularized programming.
Right. Now, Lou, guest 56979 in the chat room also has a really good question, and that is, Lou, what happens if someone types X instead of Y or N?
Good question. Yeah. So my original code actually has this, again, another sanitizer where it will basically use a conversion, a Boolean conversion. And so I'll show you what that looks like. So this, just like we sanitize the number up here to say, make sure it's a number or an integer, we can do the same exact thing for a bool, where we do down here, we basically say, use this bool, try to parse it, add the text that they entered, and then we output whether it's, and if it doesn't parse correctly, so if they enter an X, it's going to say, I have no idea what X is, and so it'll just say false. It didn't parse it correctly, and then we can put another error code in here, error statement in here that's saying what you entered doesn't make any sense. It's not true or false or yes or no.
Right.
Okay.
Right. Now, I should also note that you could technically use a series of if-then statements here. You could say if Y, and then put within that if N.
Sure.
And then the else is you must have entered something else, and so therefore I'm just going to say,
we don't even need to convert it. You're right. So we could even do it down here where we just put this, right?
Yep.
And so now it says if you entered Y, we'll just use the text and then type it out, right? So it's a little easier, a little less confusing, but I like to tend to move to variables that make more sense in the program, so it's a little easier. But in this way, you can sanitize what they wrote in too if you convert it to a bool. You know what, Lou? I want to talk a bit more about that because now you know this, Snubs, because coming from Hack 5, you understand the danger of a buffer overflow, right?
Oh yeah.
Yeah, I mean that's essentially how everything gets hacked.
Yes.
And as a programmer, I know that at the beginning you just want to make it work. Yeah, we just want that. Oh yay, yatta!
It didn't break. Yay!
It didn't break, but. And Lou, I'm going to ask you to explain this when we get back from this little break. We also have to be careful to sanitize our inputs. We need to make sure that the program is going to get the input that it was expected. And that's something that I think a lot of people get lazy about, right, Lou?
Yeah, very lazy.
Very lazy.
And it happens even in normal companies too. I've seen code that's shipped code or code out on the web where people just don't realize they have to check things. They have to verify what people are entering. They call it code injection sometimes. They can inject code. Users can inject code and little input to actually execute it or remote execute code, and it causes problems.
Yeah, and it's everyone from the beginning programmer up to the Fortune 5,000 company can have that issue. We call it lazy programming, but honestly, it's probably someone who was just trying to make it work and then just never went back to make sure they were sanitizing the inputs. Now, we're going to talk about that, but first, I want to take some time to talk about our other sponsor. Now, Snubs, have you heard about Lynda?
Oh, maybe.
Maybe just a little bit, right? Yeah, because Lynda,
they're quite nice.
They're nice, and they're also the main purveyor of online knowledge. We love Lynda because, well, they're in our game. We want to teach people, and so does Lynda. But the difference is Lynda wants to give you easy to understand, step-by-step, all-range lessons in any bit of knowledge that you want to attain. Lynda.com is an online learning company that can help anyone learn creative, software, and business skills to achieve both personal and professional goals. With a Lynda.com subscription, members receive unlimited access to a vast library of current and engaging video tutorials across a wide variety of subjects, everything from creative and software skills to business negotiation and programming. At Lynda.com, you'll learn how to code, create, and build applications from the foundations of object-oriented programming in C and C++ to desktop and mobile apps for today's popular operating systems. You'll explore the fundamentals of programming, building web applications with .NET, PHP, and MySQL, and managing data with SQL databases, connecting to cloud services, and so much more. We use Lynda.com here on the show, both in Coding 101 and in Know-How, because, well, in trying to achieve the knowledge that we can give to you, sometimes we need a refresher course. So we can jump into Lynda.com and it will refresh my knowledge about C or C++. I can go back over the lessons and recall the stuff that I've forgotten after so many years of disuse. And that's really one of the things that I like so much about Lynda.com, which is they're not just a place to learn, they're a place to relearn. Now, Lynda lets you improve your skills, learn new software, and keep up with technology. They have over 2,000 courses with more added daily. Right now, the popular course topics include Foundations of Programming, HTML, PHP with MySQL, Objective-C, Java, JavaScript, and WordPress. Their instructors are working professionals at the top of their fields and expert teachers. That is so important. You need people who don't just know the knowledge, but have actually used it in the real world, so they can give you the hints you need to become a creative, successful professional. They have high-quality video productions from state-of-the-art studios, and, you know, Snubs, these aren't those homemade videos that we sometimes see. I'm not knocking those people. I mean, I think it's great that they want to get their content out, but you can't look at the same shot for 30 minutes and listen to bad audio and bad lighting. You need something that was done right, and that's what you get with Lynda.com. You also get curated course content. Each Lynda.com course is carefully structured so that users can learn from start to finish, or, like I do, jump to a specific chapter to answer a specific question. You get easy-to-follow videos that can help you find the answers that you need, and searchable transcripts even let you search within a video to save you time and find exactly what you're looking for. They have courses for all experience levels, from beginners to intermediate and advanced, covering a wide range of technical skills, creative techniques, business strategies, and more. You can watch from your computer, tablet, or mobile device, and you can even switch and pick up the chapter where you left off. In other words, learn at your own pace, on your own schedule, on your own time, when you want to. So here's what we'd like you to do, all you Coding 101 sorts. It's only $25 a month to access Lynda's entire course library. Or for $37.50 a month, you can subscribe to the premium plan, which includes exercise files that let you follow along with the instructor's projects using the exact same assets. And you can try Lynda.com right now with a free 7-day trial. Visit Lynda.com/C101 to access the entire library. That's over 2,000 courses free for 7 days. That's Lynda.com/C101. And we thank Lynda for their support of Coding 101. Now, Snubs, we're talking about sanitization of inputs, right?
Yeah, sounds like something I learned in restaurant management courses in college.
Yeah, right? It sounds weird. Sanitize. Make sure to clean before you come back to your coder. But no, Lou, we're not talking about that. What does it mean to sanitize your inputs?
So it means to basically so like, for instance, if you're asking them for a number, you got to make sure that they're going to give you a number. If they're asking you for a specific piece of text, that you're not going to put some crazy funky command in there that potentially could execute on your application. Ooh. And so, like, for instance, if I ask for yes or no, I'm going to make sure that there's yes or no. In this case, I'm doing a comparison here saying if they entered yes, then set it to true. Otherwise, if they didn't, then I'm just going to consider it false. And that's all I consider. I don't consider any other input here. So if they enter X, Y, Z, it's just going to say, oh, it's probably false and move on. And so this way it guarantees what the user is entering. It pertains to what they were asked.
Now, we talked about this briefly when we did the section on variables, right? We talked about what could possibly happen if you didn't sanitize. But I know there's a lot of programmers out there who are like, oh, this is just a yes or no. How could this possibly affect anything? Lou, do you want to explain why a buffer overflow works?
Sure. So each variable has a type, and that type has a certain amount of space that it can handle in memory. And so when you compile your app, it only checks to say, okay, the user is going to enter in a 32-bit value here. So whatever that number is, right? And so if they start entering things in that potentially are larger than that value, then the memory space is not enough. And then the operating system just basically says, oh, or the process says, oh, I can't handle this, and it will crash. And so these are the types of things that the developer has to make sure that say, well, if the user's asked a question, they need to type in or enter within the constraints that I specify. And so that's why you see a lot of what they call checking, variable checking or input checking when you're typing into like a web page. It says, you can't enter text in the phone number field, that kind of thing. It's because they want to make sure they don't get into that type of trouble. Right,
right. Now, if we're lucky, the program will crash. Snubs, if we're not lucky and we don't sanitize the inputs, what could happen?
Buffer overflow.
Buffer overflow, right. Which means that, believe it or not, if you have a really poorly constructed program, someone could actually respond to an input with code.
Hacks.
Hacks that actually gets written into the memory and gets executed, and suddenly you're owned.
And that's how people get owned.
And that's the story of how we get owned. Now, Snubs, how about this? Follow me on this. What do you think about making for a homework assignment? Just ask our code monkeys to go out there, take any of the code that we've given them so far, do a program that inputs something and sanitize it, right?
Yeah, I think that's a great idea.
Create something that asks for a number and then checks to make sure that they're not giving us letters, that they're not giving us characters, that they're not giving us a number that's too big, right?
Yeah, absolutely.
And you could use any of the tools that we've already given to you. You could go really advanced and you use Lou's super cheating way of parsing your string, or you could use a series of if-else statements to check the line.
I'm going to try to do some if-elses.
Yeah, that's what's
I'm going to try my best.
It's actually, that's a great exercise because it gets you in the mindset of, okay, this step 1, step 2, step 3, step 4.
Yes, exactly. You always have to have your ending step if you want your beginning step to work, it seems like, if that makes sense.
Yeah. Now, Lou, we're going to come back next time. Are you willing to be our code warrior again?
Oh, definitely. Love it.
Yay!
I love it. Now, tell the folks at home where they can find you. I mean, I know you're all over the TWiT TV network, but if they wanted to find just Lou, where should they go?
Sure. Twitter.com/@LouMM or about.me LouMM. So find me over there.
Thank you, Lou. You are an awesome code warrior.
Thanks, guys.
Now, don't forget to visit our show page at twit.tv/code and subscribe. Also, make sure that you download our episodes in any format that you want, and that's where you'll find our show notes and the link to our GitHub, which is what you need if you want to do the homework. Yeah.
Yay, so much fun. So that's over at twit.tv/code, is that correct?
That's correct.
Awesome. And you can also find us over at iTunes if you want to be our iCoder. I think we're still up pretty high over there on iTunes,
top 10,
which is
top
pretty
10 video
exciting.
podcast, which is weird. Yeah.
So check us out. Just search us on there. It's Coding 101. We have our video ones up there as well as, I believe, audio as well.
Yeah, yeah. And as long as you're going to follow us on iTunes, why not jump over to our YouTube page at youtube.com/twitcoding101. You'll be able to find all of our videos, and if you join that community, you'll find out when we're going to do our Hangouts.
Wow, look at that. We're almost 2,000.
And I love our startup screen.
Yay!
Yay!
So cool. I'm so proud of us. And we also have a Google Plus community if you want to join that. That's where I found the ASCII art from one of our viewers as well. That is over at gplus.to/twitcoding101. If that doesn't work, I also made a tiny URL, tinyurl.com/coding101.
Yeah, we're having some issues right now with the G+ shortcuts. A lot of them have disappeared. We're not really sure what's going on.
Yeah, it's weird.
I think Google hates us.
Or you could just search us on Google+.
Yeah,
that works as well.
I blame Eric Duckman. Now, if you're not into the G+ groove, you can also find us on Twitter. That's actually a really good way to get a hold of us.
Oh, yeah.
I'm at Padre SJ.
I'm at Snubs.
Yeah, and finally, you can watch us each week live. We do this live on Thursdays at 1:30 p.m.
You get to see us mess up.
You get to see us mess up, right? Yeah, if you watch us live, you can see the pre-show, you can see the post-show. I can almost guarantee you that there's going to be some dancing, and you're going to see all the bloopers that don't end up in the finished product. Yeah.
It's true.
It's very true.
So that's over at live.twit.tv, and we're also on IRC, irc.twit.tv, if you want to join in and answer any viewer questions while we are recording the show.
That's right. So I think this is the time where I say, I'm Father Robert Ballecer.
I'm Shannon Morse.
End of line.